Happy Friday, everybody. Today we are going to be working on multiplying negative numbers. And so let's go ahead and look at our warm-up. So we are going to be looking at distance, rate, and time. And so the first question, an airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? So we know the speed and we know the time, and we're trying to find the distance. The second question, a train moves at a constant speed and travels 6 miles in 4 minutes. So we know the distance and we know the time. What is its speed in miles per minute? So we're trying to find a rate. And a car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? So we know the speed, we know the rate, and we know the distance, and we're trying to find the time for this problem. Go ahead and take about 5 minutes to solve this yourself. All right, so if an airplane is moving at a constant speed of 120 miles per hour for 3 hours, that means in the first hour they go 120 miles, the second hour they go 120 miles, and the third hour they go 120 miles again. So I want to know what the total distance it would be. So the easiest way to find that would be 120 times 3, which is going to be 360. So the airplane went 360 miles in the 3 hours. The second problem, if a train is moving at a constant speed and travels 6 miles in 4 minutes, and I want to know the speed in miles per minute. Per means 1 minute, so I want to know in 1 minute how far it would go. Well, I can make a table where my table would be miles and minutes. And we went 6 miles in 4 minutes. I want to know 1 minute, so I'm going to divide both sides by 4. And 6 divided by 4 is 1.5. So the speed is 1.5 miles per minute. Last problem. A car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? So the first hour, it would have traveled 50 miles. Second hour, 50 miles. Third hour, 50 miles. So how long would it take to go 200 miles? Well, I would take 200 divided by 50 to figure out how many hours it would take. And that would be 4. So it took 4 hours. Without dividing, if in the first hour they went 50, that means after 2 hours they would have went 100. And so 3 hours they would have went 150 miles. And then finally the 4th hour they would have went 200 miles. All right. Let's move on with the tasks for today. So we're going to use this number line to help us fill out our table. And then we're going to write an expression to represent the end position that uses the starting position, the speed, and the time. And our first row is done for us. So our starting position is always 0. It tells us which direction we went, either right towards positive numbers or to the left towards negative numbers. It tells us our speed in units per second, and it tells us how many seconds we went, and it wants to know where we would end. So if we started at point 0 and we are moving towards the right at 5 units per second, and when we go for 3 seconds, then if we go 1 second would be 5, 2 seconds would be 10, and 3 seconds would be a positive 15. The expression they wrote is our starting point, which is 0, plus our speed times the seconds. So 0 plus 5 times 3. 5 times 3 is 15, and 0 plus 15 is 15. So take 5 minutes, try and fill out the rest of this table, and then come back. All right, so if we start at 0 again and we move left, that means we're moving towards negative numbers. So we are moving 4 units per second for 6 seconds. So if I move 1 second, that would be -4. If I move another, that would be -8, and then -12, -16, -20, and finally -24. So our ending position would be -24. Our expression is, again, we start at the starting position, which is 0. And then we would add, since we are moving to the left, we would actually have a negative number. And we're moving a -4 spaces every 6 seconds. So -4 times 6. -4 times 6 is going to be a -24, plus 0 is still a -24. So again, we have a starting position of 0. And this time we're moving right 2 spaces per second. And we're going for 8 seconds. So 1, 2, 3, 4, 5, 6, 7, 8. We landed on a positive 16. So this would be 0 plus our speed, which is 2, times the time, which is 8. We're doing a positive 2 because we're moving to the right. So now the direction, we're still moving to the right. Starting position is still 0. This time we're moving 6 units per second for 2 seconds. So in the first second, we would move 6. Second, we would move to 12. So our ending position would be a positive 12. And for our expression, again, we start at 0. Our speed is 6, and it's going to be a positive 6 because we're moving to the right, times 2 for seconds. 6 times 2 is 12, plus 0 is a positive 12. And last, we have a decimal. This decimal, we are moving to the left, and it's going to be kind of hard to show the decimal on the line. So let's see if we can write an expression first and then find our ending position. Well, we have this same pattern with everything. So we're going to start at 0 because that's our starting point. And we're going to add our speed. Since we're moving to the left, it's going to be negative, times our seconds, which is 5. If I type this into my calculator, don't forget your negative sign. I'm going to get a negative 5.5. If I add that to 0, I'm still going to have a negative 5.5. Okay, so how can we see the direction of movement in our expressions? How did we see if we went to the right or if we went to the left? Well, if we went to the right, we used positive numbers to show the speed. And if we move to the left, that is shown through a negative speed, a negative number. Okay, let's move on to the next task. So a traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive, and to the west are negative, where 0 is where the camera is. Vehicles that are traveling towards the east have a positive velocity, and vehicles that are traveling towards the west having negative velocity. So if we're moving towards the west, that means we're actually starting on the east and moving towards the west. So we'd first have positive numbers, and then we would work our way towards the negatives. If we were moving from the west to the east, if we were traveling east, we would start at negative numbers until we reach 0, and then we would have positive numbers. So we are going to fill out this table to show the ending position and writing equations of the cars that the camera saw. And so the first one is done for us. So the velocity was positive 25 meters per second. Since it is a positive velocity, that means we are moving towards the east. The time after passing the camera in seconds was 10. So the ending position in meters is going to be 250 because 25 times 10 is 250. Go ahead and take 5 minutes to try and fill this table out yourself and then come back. Okay, so our velocity is negative 20 meters. Since it's a negative number, that means we are moving towards the west. Time after passing the camera was 30 seconds. So I am going to do the exact same thing they did over here. Negative 20 times a positive 30. If I type that into my calculator, I'm going to get a negative 600. So my ending position in meters is going to be a negative 600. So my velocity in meters is a positive 32, meaning we are moving towards the east. Time after passing the camera in seconds is going to be 40. So again, it's going to be 32 times 40, both of those being positive. It's going to be 1,280, a positive 1,280. So we have another negative, which means the car was moving towards the west, and so our velocity is negative 35, and the time after passing the camera in seconds is a positive 20. So negative 35 times 20 is going to be a negative 700. And last but not least, our velocity was a positive 28, meaning they were moving towards the east. And the time after passing the camera in seconds is 0. Well, any number, even 28 times 0, is going to give us 0. So the ending position in meters is 0. And remember, a 0 can neither be positive nor negative. It is neutral. It's the middle ground, so you don't need to add a positive or negative sign to that. So let's look at these questions about our table. If a car is traveling east when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? If we multiply two positive numbers, is the result positive or negative? Third question. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? If we multiply a positive and a negative number, is the result positive or negative? So remember, going back to this, if we are moving towards the east, that means we started at the west and we worked our way east into positive numbers. If we are moving west, that means we started in positive numbers and we worked our way towards the negative. So If a car is traveling east, that means we are going to end in a positive number. So, moving east or to the right is going to result in a positive 60 seconds. So this is going to be positive. Now, the second question, if we multiply two positives together, so a positive times a positive, if we look over here, positive times positive is going to give us a positive. A positive times a positive is going to give us a positive. If a car is traveling west when the camera passes, so that's meaning it's moving from east to west or towards the left, that is going to result in a negative 60 because we're moving towards the left of 0. So that's going to be a negative number. And so for the last question, if we multiply a positive times a negative, our answer, if we look over here, negative 20 times 30, negative 35 times 30, those both ended with a negative number as our answer. Okay, that's because if we look at this problem over here, so our speed was 4 units to the left per second for 6 seconds. So if I'm moving towards the left for 6 seconds, 1, 2, 3, 4, 5, 6, we're going to still end up in the negatives. Okay. So now backwards in time. A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive and to the west are negative. So just like we looked at, when you move to the right, you're going to be positive, and when you move to the left, you're going to be negative. So we have 4 questions. In what direction is the car moving? What is its velocity? So what is the feet per second? And what does it mean when the time is 0? And what could it mean to have a negative time? Take 5 minutes to try and fill that out, and then come back. All right, so 0 is where our camera is. So after 1 second after the camera, we had a positive number. So this means that the car was moving east. The velocity is the feet per second. So this is going to be a positive 60 feet per second. I know this because at 1 second, we were at 60 feet. So after 1 second, we were at 60 feet because from 0 to 1, that's 1 second. From 0 to 60, that's also 60 feet. So what does it mean when the time is 0? That's when they passed the camera. So that is the time the car passed the camera. What could it mean to have a negative number? Well, these negative numbers are the times before the car passed the camera. So if this is 1 second after the car passed the camera, then that means our negative numbers are all the time before they passed. So we have a very similar table, and they're asking us to complete the new table with the rest of the positions if the car has a velocity of negative 50 feet per second. And then I want to know, in what direction is the car moving? Take 5 minutes for this. Okay, so if 1 second after they passed, they were at a negative 50 feet, then that means 1 second before the car passed, they would be at a positive 50 feet away. And then 1 second before that, they would be at a positive 100 feet. And before that, they would be at a positive 150 feet. Well, since the car is moving from positives to negative numbers, that means our car has to be moving west. I know this because the velocity is negative. All right. We started at positive. Which is to the right. And move to negative, which is the left. Okay. Let's go ahead and move on. So we have now several different cars, the different velocities, the time after passing the camera, the ending position in meters, and an equation. The first one is filled out for you. For a velocity of positive 25 meters per second and a positive 10 seconds after passing the camera, the ending position would be 250 because the equation would be 25 times 10, which equals 250. Take 5 minutes to fill out the rest of the table and then come on back. So now the velocity is a negative 20 and the time after passing the camera in seconds is a positive 30. So our equation would be negative 20 times positive 30, which is going to give me a negative 600. So the ending position would be negative 600. Since the velocity is negative, that means they are moving towards the west. Their ending position is a negative number. They're moving towards the west, towards the left. So our velocity is a positive 32, which means they're moving towards the east. And the time after passing the camera in seconds is negative 40. Well, if we have a negative number for the time passing the camera, that means they haven't even passed the camera yet. So this is actually the time before they pass the camera. So again, we're still going to multiply these out. So that'd be a positive 32 times a negative 40. And since it's a positive times a negative, 32 times negative 40 is going to be negative 1,280. And so now we have a negative velocity of 35, which means we're moving towards the west. And we have a negative 20 for our time after passing the camera, which again, since that's negative, that means they have not passed the camera yet. And so what's odd about this is that since we're moving from the east to the west, and we have not passed point 0 yet, we have not passed the camera, that means oddly our answer is going to be a positive. So a negative 35 times a negative 20 is going to be a positive 700. Same thing here. We have a velocity of negative 15, which means we are moving towards the west. We have a negative time after passing the camera, which means we have yet to pass the camera, meaning our ending position is going to be a positive like the last one we just saw. So negative 15, 15 not 18, times a negative 8 is going to be a positive 120. Okay. Now we have a few questions to answer about that table. If a car is traveling east when it passes the camera, will its position be positive or negative 60 seconds before it passes the camera? If we multiply a positive number and a negative number, is the result positive or negative? If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds before it passes the camera? So if we multiply the two negative numbers, is the result positive or negative? So first, let's look at this. So if a car is traveling east when it passes the camera, will it be positive or negative before it passes the camera? Well, we're moving east. Before it passes the camera, all of the numbers are negative. So this would be a negative 60 seconds. So that's going to be a negative. So if we multiply a positive number and a negative number, so a positive times a negative, if we look over here, we have a positive 30 and a negative 20, and when we multiply that, we ended up with a negative number. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds before it passes the camera? Well, if we're moving west 60 seconds before we pass, we would end up with positive numbers. So this would be a positive 60 seconds. And now, last, if we multiply two negative numbers together, our result, like the last two, is actually going to be positive. All right. So now, we can choose a 0 point, and then positive and negative numbers can represent positions to the right or left of this 0 point. So we saw that when we were talking about the velocity, and then even going right or left. Signed numbers can also be used to represent speed in opposite directions. This is called velocity. So when we were moving towards the east, we would end with a positive. When we were moving towards the west, we would end with a negative number. Positive times are often a chosen zero time, and negative times are times before the chosen zero. So we saw that here. So we have a negative 40 seconds, which means it was 40 seconds before it passed the camera. A negative 20 was negative 20 seconds before it passed the camera. A positive times a positive is always positive. So we see that right here. Positive 25 times positive 10 is a positive 250. A negative times a positive, or a positive times a negative, is always negative. So we see that in card D. Negative 20 times a positive 30 gives us a negative 60. A negative 40 times a positive 32 gives us a negative 1,280. A negative times a negative is always positive. And we see that in the last two. A negative 15 times a negative 8 gives us a positive 120. Or a negative 35 times a negative 20 gives us a positive 700. So, hopefully, you can multiply a positive number with a negative number and a negative number with a negative number, and you can use rational numbers to represent speed and direction. So, I hope you guys have a lovely weekend and a lovely Friday. Don't forget to do your Go Formative. The Go Formative is Unit 5, Lesson 5. Okay, have a great day, guys.